So this is the physical science lesson video for section 8.1, and as always, if you like my videos for all of physical science in one spot, just subscribe to my channel. So in chapter 8 we talk about a few different things. We talk about solutions, acids, and bases. So let's get started talking about solutions, because when we're talking about acids and bases, they're usually in the form of solutions. So every solution has two types of components. A solute is a substance whose particles are dissolved in a solution, and the substance in which the solute dissolves is called the solvent. So what I like to say to help my students remember it is the solvent dissolves the solute. So for example, if we're talking about Kool-Aid, does it make sense to say the Kool-Aid powder dissolves the water? No. Okay, so the solvent dissolves the solute, the water dissolves the Kool-Aid powder. So water would be the solvent, Kool-Aid powder would be the solute. The solute is what is actually dissolved. The solvent is what dissolves the solute. So substances can dissolve in water in three ways: by dissociation, dispersion, and ionization. Dissociation, dispersion, ionization. So dissociation of ionic compounds. For a solute to dissolve in water, the solute and solvent particles must attract one another. If they don't form attractions, then it won't dissolve, because not everything dissolves in every solvent. The process in which an ionic compound separates into ions as it's dissolved is called dissociation. So this is salt. So we see all our NaCl's and they're all bonded together with an ionic bond. When we put salt in water, we know it dissolves. So what happens is the water molecules, they're attracted to those positive sodium ions and negative chloride ions. And so they kind of surround them. You can see how they surround the particles. And so they pull those ions apart. And so that is referred to as dissociation. Dispersion. Sugar dissolves in water by dispersion, or breaking into small pieces that spread throughout the water. So on the other hand, sugar is, if we're talking about the sugar we eat, we're talking about sucrose, which is C12H22O11, it breaks up into its individual molecules. Okay, so these are just a bunch of sugar molecules together, and so when we put it in water, because we all know sugar dissolves in water, it kind of pulls the molecules apart from one another. So it's still C12H22O11, it's just not a group of them, it's just a single molecule at that point. And then ionization. The process in which neutral molecules gain or lose electrons is known as ionization. Unlike dissociation and dispersion, so in dissociation we just pulled two ions apart. In dispersion, they kept their normal charges. In dispersion, we just break down molecules into smaller particles, but it's still the same molecules, which are physical changes. Dissolving by ionization is a chemical change. So ionization, because we're actually changing the charges of the substances, that is a chemical change. Alright, so like for example, if we have HCl and we put it into water, it becomes H3O plus and Cl minus. So it's actually changed into new substances or changed composition. So properties of liquid solutions. Three physical properties of a solution that can differ from those of the solute and solvent are conductivity, freezing point, and boiling point. So whereas a solid solute may not be conductive, when we dissolve it in water, it might be conductive. So here we have a solute, we have our solvent, which is water. When we dissolve it, it will conduct electricity, because this right here is cupric sulfate or copper 2 sulfate. In a solid form, remember the ions can't move, they're in those fixed locations. Once we dissolve it in water, the ions can move. And remember, to conduct electricity, we need moving charges. So properties can change when we dissolve a solute into a solvent. So solid ionic compounds do not conduct electricity, because like I just said, the ions cannot move. Maybe I should click the slide before I just explained all that. When an ionic compound is dissolved in water or melted, the ions break apart and then they can move, and this allows the solution to conduct electricity. Okay, so here we have an example where we can conduct electricity. Here we have an example where we cannot, and of course we have a light bulb that is off. In this case, they're basing it on charged particles versus neutral particles. But in our example, we're talking about, can the charges move or can they not? Freezing point. Ice forms when water molecules are able to arrange themselves in a rigid honeycomb-like structure. The presence of other solute ions, which are attracted to the water molecules, interferes with the freezing point. A solute will lower the freezing point of a solvent. So when water forms ice, the molecules get in a honeycomb shape. That's like a hexagon, a 6-membered ring. So if you add a solute, it prohibits the honeycomb shape from forming, so the water can't freeze. So what we have to do is we have to lower the temperature even more to force the water molecules to freeze. And so that means the freezing point is lower when something has been dissolved in water. Boiling point. A solute can also raise the boiling point of a solvent. So again, we've talked about the attractions formed between the solute and the solvent particles. They're attracted to one another. So when you try to boil it, we need the solvent to become a gas. We need the water molecules to leave and become a gas. Well, remember, they're attracted to those solute particles that we've added. So they don't want to leave and become a gas. So we have to heat it even higher or raise the boiling point in order to force the water to boil, or the solvent. During the formation of a solution, energy is either released or absorbed. So we've talked about other chemical and physical processes where energy is released and absorbed, and so this is just another one of them. The solution process can be exothermic or endothermic. So remember, exothermic means energy is released or exits the reaction, and endothermic means energy enters or comes into or is absorbed by the reaction, or physical change in this case. So how can we speed up dissolving? Because if we want to dissolve something, we want to dissolve it now. So the rate of dissolving depends on the number of collisions between the particles of the solute and solvent. So if you watch the video about reaction rates, speeding up dissolving is very similar. So factors that affect the rate of dissolving include surface area, stirring, and temperature. So the greater the surface area, the more frequent the collisions are between the solute and solvent particles. So remember, surface area and particle size are related. The more surface area, the smaller the particles. So think about if you're trying to dissolve sugar. Do you want to dissolve sugar cubes, or do you want to dissolve that granulated sugar? Well, that's a much smaller particle with more surface area. So we don't want to try to dissolve those sugar cubes. They're going to take a lot longer. So remember, dissolving happens at the surface. So the more surface you have, the faster dissolving can occur. Stirring. Remember, if you just dump a solid into a liquid, where's it going to go? It's going to settle right at the bottom. So all this water at the top is not going to be able to help dissolve it. So if you stir it up, you disperse those particles and allow more collisions to occur. So stirring moves dissolved particles away from the surface of the solid and allows more collisions between the solute and solvent particles. Again, you don't want a big clump of the solid just sitting at the bottom. It's going to take a while for that to dissolve. We want to disperse it and spread it out. And then increasing the temperature of a solvent causes the particles to move faster. As a result, both the number of both the number of collisions and the energy of the collisions with solute particles increases. So here we have cold water. You can see we have a purple streak right here. Here we have hot water, and the purple has spread throughout. So the hotter the substance, the faster the particles are moving, so the more collisions, so the faster it can dissolve. Again, these are the same 3 explanations we gave for when we talked about how to increase reaction rate. So, section 8.1, assessment. What are 3 ways that substances can dissolve in water? You have dissociation, dispersion, ionization. Dissociation, dispersion, and ionization. Number 2, what physical properties of a solution differ from those of its solutes and solvent? Well, we have conductivity, freezing point, and boiling point. Conductivity, freezing point, and boiling point. Number 3, how does the formation of a solution involve energy? Remember, it can either absorb or release energy. It depends on what the interaction is. Okay, so it can absorb or release energy. And then number 4, what factors affect dissolving rates? We said stirring, surface area, and temperature. Stirring, surface area, and temperature. Alright, so hopefully now you understand a little bit more about the basics of solutions and how to dissolve something faster and what changes about a solution once it's made.